Dobro jutro, welcome everybody. To sekcijo bomo imeli več ali manj v angleščini, ker se nam pridruži tudi tuji gost, Roman Jangarberger. And I would really like to welcome you. The topic of this section is on language technologies. As briefly introduced in many opening speeches yesterday, it's more and more linked to linguistics. And the first speaker will be Tomaž Erjavec from Jožef Stefan Institute, one of the persons most linked to language technologies for Slovene language. So, Tomaž, the floor is yours.
Thank you. So I actually prepared these slides in Slovenian, but then have been asked to present in English, so I hope you don't mind the bilinguality of the talk. So what I will talk about is automatic extraction of word formation rules and chains for Slovenian language. As a short introduction, so what I will do is present a computerized method to basically support word formation analysis for Slovenian. And the basis on which all this work is based is the word family dictionary of Slovenian language. This was a trial volume, and it consists just of the head words which start with B, and it is the author is Irena Stramlić-Breznik, and it was published in 2004. By itself, it's relatively thick for just one letter of the alphabet. And what we wanted to do with this dictionary was to try and learn rules from the dictionary that we can then use to identify new word formation candidates from pair root or the source word into the target word, which is then a word formation from the source word. So this was the question, can we do this? For the dictionary, we were very lucky because it was actually made on a computer by a dedicated program which stored all the information in the dictionary as a basically as a database. And the first thing we did was then convert this database into something which is used a lot more in computational linguistics and digital humanities in general, which is an XML format. It's so-called TI-Leg0, which is becoming increasingly popular in digital humanities. It's not really a standard, but it is becoming a best practice in encoding digital dictionaries. So here you have an example. Going back now, this is, I'm not sure how familiar you are with XML, probably not a lot. It's very similar to HTML. And what it says here is that we're starting an entry which is in Slovenian language, and it is of type main entry, and it then also has an ID, so you can point to it. And then inside it has the form, which gives the orthography of the head word, which is baba in this case, and also its pronunciation, so the stress is on the first syllable. And then it gives 3 grammar groups. This is the grammatical information on the entry. Sorry. The first one is the original grammar group from the dictionary, which says that this is a samostalnik, a noun, and that it is of gender je. This is an abbreviation for ženski, for feminine, and that's basically it, right? So now we know that baba is a noun in the feminine gender. What we did in this conversion is also convert this Slovenian grammatical information into 2 other formalisms which are used a lot in computational linguistics. One is the universal dependencies formalism, which then says here this is noun and it has gender feminine. And the other one is the so-called multext east formalism, which we developed, decades ago now, but it is still quite a lot used in Slovenian and also for other languages. And here it just says NC, and this means noun common. Yeah. So it has, it's kind of more compact. And then we come to the form which gives the morphemes of this word. And because this is the root, it just says baba again. Yeah, so far it's more or less the same as it would be in any other dictionaries. The kind of twist comes later. Down here, because we have an entry, and you can see this is actually subsumed by the entry for baba. So it's kind of inside it. I'm really sorry about this. And this one is for babai. So if we look at this one in a bit more detail, we have this entry here, which is for babai, and then again it gives the grammar group and so on. But then the difference is here in the morphemes, where it tells you that this babai is actually composed out of two morphemes. The first segment is the root, which is the bab, and the second segment is the suffix morpheme, which is I, and the same from pronunciation. So this is kind of the basic information that we do have in the dictionary now. And from this, what we wanted to do, or what we in fact did, is to induce these rules. Now, the first bullet here, we have the information that is in the dictionary, which is this bojevati, which is a verb, and it can, from it we can get the derived word, which is bojevanje, which is a noun. And what we did then is, from this rule, induce a pair of rules. One is so-called, well, what we call a deep rule, which just kind of, in a more formal manner, rewrites what we have in the first bullet, namely that we have a verb which ends in evati. We get a noun from it which ends in anje. So this is just, in a way, a mapping from the original, from the dictionary rule into this formal specification. But then we can also, from what we have in the dictionary, compute a surface rule, which says that if we have a verb which ends in t, from this one we can get a noun which ends in nye. This is kind of similar to the deep rule, but not quite, because what we have in the surface rule is just the string difference between the source and the target. Yeah? So this one we can actually apply to any pair of words to see whether this rule could possibly be the reason why one word matches the other word. Yeah? So we using this rule on a lexicon, on a dictionary of Slovene, a large one, we can see whether we can get pairs of derivational candidates. Now, I should note here that we just looked at suffixal rules, so we didn't do prefixes and compounds or interfixes, anything like that, just suffixal rules. So, on this basis, we managed from this dictionary, from the letter B, to generate 1,641 rules or pairs of rules, deep rule and surface rule. So, this is what we got from the dictionary. Now, how can we use this thing? Sorry, one more thing. The dictionary itself has word families. So that means that from one root we can get many different derivations, and one derivation, of course, can lead to another derivation and so on. So we can chain these rules together from the dictionary, and the dictionary gives us all these chains. So if we go from biti, which means to hit, probably in this sense, which is a verb, we can derive from it boy, which is a noun. It means a fight, and from this one we get bojevati, which is again a verb, which means to fight, and then we have bojevanje, which is a fighting, which is again a noun. So this is an example of one chain, and of course from the first three stay the same, but the fourth one can also be bojevališče. So you have like a tree of derivations. So in addition to the rules themselves, we also generated these chains from the dictionary, and we get 1,649 of these chains. So this is what we managed to get to extract out of the dictionary. And then the next stage is actually trying to apply these rules that we got in the chains. Now, what we need is, okay, we have the rule, but then we also need a large dictionary in order to match the pairs which a rule, so if we have the source and we apply the rule, we get something, some word, and then we have to find this target word in the dictionary. And if we find both, then we are relatively confident that this would be a legitimate, at least, candidate for a derivational pair. So what we use here is Slolex, which is a large, openly accessible morphosyntactic dictionary of Slovenian, which for each lemma has the complete paradigm, so the word forms, and what kind of morphosyntactic features they have. And so what we did then is, from this Slolex dictionary, we extracted all the not functional, but content words, and we got 85,400 lemmas. And then we tried to each of these lemma, we tried to apply each of the rules that we got. And if we find a target in the dictionary, this was then a candidate for a derivational pair. In fact, we did find quite a lot of them. So we found 117,000 pairs, and then when we chained them together, we found 32,000 chains. So this was the test on Slolex, and then the same method we also tried to apply on two other sources. One was Metafida. This is a huge corpus of Slovenian, the largest we have. It has 4 billion words, and it has been automatically annotated. So from this huge corpus, we extracted the lexicon from the corpus and tried to apply the rules. The other source we had was the Dictionary of Slovenian Language. This one has about 100,000 headwords. And again, we extracted out all the lemmas with their corresponding part of speech and so on. The results were not so good. Metafida has the problem, because it's a huge corpus, it has lots of typos in it as well. And these typos then float up in the lexicon, so we get lots of false pairs. However, we did get over 1.5 million pairs and almost 500,000 chains. And SSKJ, so the dictionary, this one is, of course, doesn't have any errors. So in it we found 700,000 pairs, but only 100,000 of these and 1,400 chains are not already have not already been derived from Slolex. And these are typically dialectal words or archaic words and so on, so words which most speakers of Slovenian wouldn't actually know. However, they are legitimate pairs and or chains, and can possibly be used further. We also did an evaluation of these chains that we got. So here we have what they have been extracted from. We just here looked at Slolex and Metafida. The second column is the length of the chain. The third is vzorec, is how many actually we got, and how many of these, not how many we actually got, but how many we actually evaluated, and how many were correct. So from Slolex, it's not too bad. It's from like 1/5 to 1/4 of all the candidates are actually correct. And from Metafida, it's a lot less. Yeah, we get at most 5% here. So as some sort of conclusions, I just gave you a brief introduction to this method, not very complicated method. And we try to apply it on a couple of lexicons, from which we get a lot of new rules and a lot of new chains. And this could be some sort of support for a linguist actually looking at the pairs, not to have to think them up or try to find them with some other method, but just look at these long lists that we have and then tick off, is this a legitimate derivational candidate or not? And from this, it would be then, I wouldn't say quite simple, but it would be possible to expand this dictionary with the letter B to all the other dictionary letters of the alphabet. Unfortunately, the results of this work cannot be made openly available because of the copyright on the original dictionary, for which I'm very sorry, but yeah, there you go. So with this, I would now stop and...
Thank you very much. Are there any questions from the public? If not, I have maybe one short question. So, since you were dealing mainly with suffixes, but the dictionary is on letter B, do you think this is a huge problem, or is it like a limited set of rules, or it's still sufficiently comprehensive because anyway you are not interested in the beginning of the letters, but the suffixes?
I can only guess, but my guess would be that if we have the letter B, which has quite a lot of entries actually, it probably covers, well, if not completely all, then most of the suffix rules that exist for Slovenian, or that would be covered in a dictionary containing all the letters. Yeah. So okay. I think this is quite a good basis for induction.
Thank you. Any other question? Then thank you very much, Tomaž, for your talk.